right, so we have a situation where we have two charges. We know that charge 1 is plus 8 microcoulombs. We don't know what the charge 2 is, but we know that at a given point, P, the net electric field due to these charges is equal to 0. So the first question is asking us to calculate the magnitude and a charge on Q2, meaning is it positive or negative. So if you remember, I mentioned that before we get to formulas, we really need to do a vector diagram. And what is crucial here is to understand that if the net field at point P is 0, we already know that Q1 is positive. So we know that electric field due to Q1 is to the right. Now, if the net field is supposed to be 0, the only way we can achieve that is if the Q2 is in the opposite direction. So the electric field due to this second charge has to go this way. Well, knowing the definition of the electric field and what it means, that can only happen if this charge is negative. Okay, so we know for sure that Q2 will be negative. Because otherwise, if it was positive, the electric field would be also in this direction. We would never be able to get electric field to be 0. Okay, so that's important, and that vector diagram will tell us that it has to be negative. Now let's go to calculation. Well, we know that if we add the two vectors, they have to give us 0 as a net field, and that means really that the magnitudes or the numerical values of those two electric fields have to be equal to 0. So this is pretty simple calculation. We can cancel out Q. We know that R1 is the distance between Q1 particle and the point P, which in this case is 0.4 meters. And we know that R2 is 0.2 meters. So in this case, I'm going to just start calculating, and ideally I want to solve for Q2. So I know Q1 is 8 times 10 to the power of negative 6 divided by 0.4 squared is equal to Q2 divided by 0.2 squared. Now if I isolate Q2, I will get 8 times 10 to the power of negative 6 times, and I'm going to, for a reason here, put 0.2 as a multiplication, and then I'm going to get here 0.4, which is 2 times 0.2 times 2 times 0.2. Right, so this is my 0.4 and 0.4. I do this just to show you that you can do this completely without use of the calculator. And what you get 8 times 10 to the power of negative 6 divided by 4, which is 2 times 10 to the power of negative 6. Now, you notice here that if you follow the conversion sign, you will get actually what appears to be positive number. But again, in this case, we can't use this formula to determine that value. It has to be the vector that will tells us that. So what we're going to say is that this is only magnitude. Right? So we know that charge 2 actually has to be negative 2 times 10 to the power of negative 6 coulombs. So that's the first bit of it.